Analysis of continuous LTI system can be done using Z transform. Z transform is a mathematical tool to convert differential equation into algebraic equation. For a unilateral, the unilateral Z transform of a discrete signal is given by Z transform of x of n is equal to x of z, that is nothing but summation n to infinity x to the power x of n into small z to the power of minus n. For unilateral, it is given as z transform of x of n is equal to capital X of z, that is equal to the summation n to 0 to infinity x of n z to the power minus n. So this z transform exists for which discrete time Fourier signal, that is df dt, does not exist. Z transform of a signal x of n can be represented as x of z is equal to summation n equal to minus infinity to plus infinity x of n into z to the power minus n. So if the function z is given as r of e to the power j omega, then the equation 1 can be rewritten as x of r or e to the power j omega is equal to summation n equal to infinity, that is minus infinity to plus infinity x of n into r e to the power j omega the whole power minus n. On simplifying, that is we are bringing this minus n to this r minus n power of r into this r, so that the equation is rewritten as summation n is equal to minus infinity plus infinity x of n r to the power minus n and e to the power minus j omega n. So from this the equation can be rewritten as it is the Fourier transform of x of n into r to the power minus n. So the relation between Fourier transform and Z transform is nothing but the Z transform of a signal is nothing but Fourier transform of that signal. Inverse Z transform. So x of r e to the power j omega is equal to Fourier transform of x of n into r of r to the power minus n. So this x of n r to the power minus n is equal to Fourier transform of x of r e j omega. So x of n is equal to, we are doing this to the simplification, that is r of minus n is taken to the next side, r to the power n, Fourier inverse of x of r e to the power j omega. So the equation for the Fourier transform or inverse Fourier transform is substituted here, that is 1 divided by 2 pi integration of x of r to the power j into omega into r e to the power j omega the whole power n d omega. So this equation is 3. So now we are substituting r of r e to the power j omega as z. So we are differentiating this z, that is dz is equal to j r into e to the power j omega dt, that is nothing but j is a d omega. So d omega, it is nothing but 1 by j into z inverse of dz. Substituting this in equation 3, we get x of n is equal to 1 by 2 pi integration of capital X of z into z to the power n 1 by j into z inverse dz is nothing but that is equal to 1 by 2 pi j integration of x of z into z to the power n minus 1. Also x of z is nothing but summation n equal to minus infinity to plus infinity x of n z to the power minus n. So x of n is nothing but 1 by 2 pi j into integration of x of z into z to the power n minus 1 dz. So the inverse transform, that is inverse transform of z, the inverse z transform of the signal is found out. Initial value theorem and final value theorem. These theorems are defined of Z transform are defined only for the causal signal. So in order to find the initial value of a signal without taking inverse Z transform, this initial value theorem states that for a causal signal x of n, the initial value is x of 0 is nothing but limit z tends to infinity x of z. Similarly, for a partial signal, the final value of the signal x of infinity is nothing but the limit z tends to 1, determinant of z minus 1 into x of z. So now let's see some properties of ROC of Z transform. So this ROC of Z transform is indicated with a circle in the Z plane and it does not contain any pole. If the signal x of n is finite duration causal sequence or right-sided sequence, then the ROC is in the entire plane except Z equal to 0. Similarly, if this x of n is left-sided, then the ROC is in the entire Z plane except Z equal to infinity. Also, next, if x of n is infinite duration causal sequence, this ROC is the exterior of the circle with a radius a. That is, the determination of z is greater than a. Similarly, if the ROC is interior circle, the determination of z is less than a. That is, interior to the circle. Next, if the signal x of n is finite duration of two-sided sequence, then the ROC is in the entire z plane except z equal to 0 and z equal to